Howdy, folks. It's time for lesson 63, solving systems of equations by elimination. Let's talk about what you need today. First of all, you're going to need a stencil. Stencil. Get it? You're going to need your notebook where you're going to write down your notes. Anything that goes in here, you're allowed to use on the test, so you ought to do that. Third, you're going to need that homework paper that I gave you in the email. Fourth, you need a VW van thing. Okay, you got to have one of these or else it might not work out for you. Okay, so let me describe or define a few things for you here. A system of equations is going to be two equations with x and y as variables, where there's only one answer for x and y that makes both of the equations true. Actually, systems of equations can have 3, 4, 5, we can have any number of equations as long as it's more than one. And it can have many different variables as well. It doesn't have to be just x and y. If you got 3 variables, it could be x, y, and z, but then you need 3 equations in order to solve. And elimination here means that when we line these things up in columns, we're going to get rid of one of them and solve for the other one first, and then take that answer and plug it back into one of the original equations to solve for the other one. Systems of equations get solved in lots of different ways in math. I can think of right now 5 ways that in algebra you're taught to do it: substitution, elimination. You can use a thing called Cramer's rule, which uses determinants. You can set it up as a matrix and do lots of different things there. You can graph two equations in y equals mx plus b form and find where those graphs crisscross that point, that xy point is your answer. So there's at least 5 that I can think of right now. Let me give you some strategies for how we're going to work on this today with this method of elimination. And we'll get all this written down, and then what I'll do is I'll demonstrate how these things work in real problems. First of all, key strategy, we're going to look for variables like x's and y's that have opposite signs. So you look for, in one equation, you're looking for something like, it says plus 2x, and in the other equation it says minus 2x. We can combine those two equations to get rid of the x's right away. Second, we're going to change equations into the standard form first to compare and combine. And I'll talk to you about what standard form means here in just a minute. So again, this is linear algebra, and linear algebra involves lines and matrices and vectors and a whole bunch of things. And it's not really super complicated, but it will lend itself to things later on like computer programming and matrices. So there's some rules that you play by when you're doing linear algebra. Things that you can do to equations, and you're not changing their values, or you're not changing the truthfulness. The left side still equals the right side without getting a different kind of answer at the end. So one of those things you can do that we'll start with is combining. And the book separates combining into specific separate add 2 equations together and subtract 2 equations together. I like to put that all in one category because subtracting is just adding a negative value. Okay, so we're going to call it combining 2 equations by either subtracting or adding or subtracting 2 equations together, squish them together. Also, you can multiply one equation by a non-zero constant. If you do multiply an equation by 0, it disappears and you just totally trash the thing. So it has to be a non-zero constant to get a brand new equation that's also true. And then even then you can combine it with one of your original equations to work it out. Or thirdly, you can multiply both equations in a system of equations by different non-zero constants to get what's called the lowest common multiple of those numbers that are opposites. So you'd be multiplying one and the other by different numbers, so that maybe it's 2 and 5, and you multiply the 2 by 5, you multiply the 5 by negative 2, so that you have 10 and negative 10, which can then cancel each other out or eliminate. So those are the strategies we're going to demonstrate. I'm going to give you a few different systems of equations and work them out on the board. And that should give you enough to help you finish out that lesson. So let me clear the board and set it up with some problems. Okay, I've got our first setup here of a system of equations that we're going to eliminate. First thing I want to say about systems of equations, when I was in school in 1912, the way that we did this was that we put a bracket next to these equations to show you that these two went together, that they were a system, that there is one solution, an XY solution that satisfied both equations. So I'm going to be doing that. They don't do that in the new books, but that's the way I learned, so that's what I'm going to do. Second, I have over here what's called standard form. Standard form is when both the x variable and the y variable are on the same side of the equal sign together. And I'm going to put them on the left, just for convention's sake. And then we have a non-zero, well, we have a constant over here. It could be 0, that's fine. We have a constant over here on this side. The a and the b are called coefficients, the big numbers. The x and the y are called variables. And over here, the e is called a constant. And then I just picked different numbers and letters for my second one. Cx plus dy equals f, and then I would combine the two of them, connect the two of them with a bracket. So there's our standard form, and sometimes the equation has to be moved. The x's and the y's have to move over here, the constants over out here, so that we have the x's in one column, the y's in another, and the constants in their own column. That will help once we get to solving these things by matrices. So let's look over here right now. One of the keys that we were looking for was having things that were the same number but different signs. And if that's the case, what we're going to do here is we're going to combine these two equations, like I put a big old like a plus mark there, and just add straight down these columns and rewrite it and get a new equation. So we have 7x minus 3x is 4x. Negative 4y and a positive 4y makes 0y. So that's eliminated right there. Equals negative 3 and negative 1 is negative 4. So if we do our basic algebra here, we'll get that x equals negative 1. And that's part of my answer. I'm going to put that over here, negative 1 and something. So at this point, I can go back to either of these original equations and solve for the other part of it, since I know now what x equals. And I'm going to go ahead and I'm going to put that right here. I could do it with that one too, but this one will work just fine. So if I go ahead and I do this, negative 3 times negative 1 is 3, plus 4y equals negative 1. I'm going to subtract 3 from both sides, 4y equals negative 4, and then finish it off, y equals negative 1. The answer to both of these solutions, the solution to both of these equations is going to be negative 1 for x and negative 1 for y. Let's make sure that that's true. Is 3 minus 4 negative 1? Yes, it is. And is negative 7 plus 4 negative 3? Yes, that's true as well. So there's our first one. We'll look for opposite signs, same number. We can eliminate one of the variables. If we wanted to, we could eliminate x first. It doesn't matter. You get more choices the more math you do as far as which one you want to do first. But you want to take the math of least resistance. And that one was set up already to get rid of the y's. So we went ahead and did it that way first. Okay, next we get an example of subtracting, or as I said, subtracting is the same thing as multiplying by negative 1 and adding. So I'll show you kind of both of those really quickly here. So we see here that we have opposite signs on the x's, on the x coefficients, but different numbers. So that's a problem. And over here we have the same number, but we have the same sign as well, so that's a problem too. There's neither of these that we can eliminate right now the way that this thing is written. I'm going to put my bracket there and connect these two equations together. So one thing you could do is to put parentheses around that whole second equation and subtract. And that means that I'm going to go 2x minus negative 3x. 2x plus 3x is 5x. And then I can go 2y minus 2y There I get my elimination if I do it that way. So let's finish this one off. We'll get 6 minus 11 is negative 5, and we can see right away that x is going to be negative 1. We use the same method and then take that negative 1 and plug it into either of these equations to solve for y and finish that one off. But, as I said before, subtracting is the same thing as multiplying by negative 1 and then adding. Here's something we can do that's kind of the next step, and that would be multiplying one of the equations by a non-zero constant and then combining. So I'm going to multiply this second equation by negative 1. And what that does is it just changes all the signs in that equation. So this one would become 3x minus 2y equals negative 11. And I'm going to rewrite this top equation right here. The order of the equations does not matter, so I can combine them this way. Here's my new equation, and combine it with the first equation. Combine means just add here 5x. That gets eliminated. And what do we get over here? Negative 5. We get the same answer for x. We get to the same exact point if we do it that way compared to the other way. So this is kind of like the third example where we're going to multiply it by some non-zero constant and come up with a new equation that we can combine with one of the original equations. I'll give you, I think, 2 more examples, and then you can get to your work. Okay, let's take a quick look at this equation right here. Different numbers, same sign. Different signs, different numbers as well. We need them to be the same number, but with different signs. So we can, let's see, I think the easiest thing to find first is the opposite signs. That makes this easier. It'd be easier to get rid of the y's and then rid of the x's, because we'd have to make one of the x's negative and multiply it by a number to get them opposites. This one's already opposite signs, so what I'm going to do is I'm going to multiply that top equation by 2. And that'll change that equation to 2x and 2y equals 6. And now here's my new equations that I'm going to combine. Here's my new system of equations. And I'm just put them together and get 5x. The y's eliminate. And then we get over here negative 11 and 6. We're back to where we were before, right? And now we know that x is negative 1 and can go from there. Once we know that x is negative 1, you go back to this one here, negative 1 and y equals 3, and it's easy to solve for y. Okay, that was a pretty quick one. I'll give you one more. This is as crazy as they're going to get for this one. Got to move fast here, though. And, ooh, yuck. I'm going to have to find least common multiple here. This is going to be tough. 2 and 5 is way easier to find. If I go 2, 4, 6, 8, 10, and 5, 10, there we go. But the signs have to be opposite. So I can do a couple of different things. I can either multiply this one by 5 and this one by negative 2 to make up 2 new equations. This one would be, top one would be 30x and 10y equals negative 70. And the bottom one would be negative 30. And well, I guess that would be negative 10, and we get negative 100. That's one way. You can actually get rid of a bunch of stuff that way. That one doesn't help too much. Or we can multiply the top one by negative 5 and the bottom one by 2. In both cases, that will make the y's go away, and the signs will be different. So you might want to try that. I got one more type of problem to talk to you about in like 50 seconds, so here we go. Actually, I decided that's not enough time. So I'll make a short, like 2-minute video for lesson 63, part 2. We'll talk about what I call the coin problem. This comes in lots of different forms. It's not just coins, but yeah, I'll set that up for you on the next little video, and it'll be about 2 or 3 minutes long, so we can cover that sufficiently. Okay, well, all I gotta say is Merry Christmas and Happy Birthday.